Hey guys, welcome to IGCSE Add Math topical questions. And today we'll be doing the 2024 papers for vectors in 2D. So let's get started. The diagram shows a parallelogram OABC. The point D divides the line OC in the ratio 2 to 3. So we can write OD as 2 over 5 and DC will be 3 over 5. OA equals to A and OC equals to C. So OD will be 2 over 5C and DC will be 3 over 5C. The point P lies on AD such that OP equals to a scale factor of OB and AP equals to another scale factor of AD. And these are scalars. Find two expressions for OP, each in terms of A, C, and a scalar, and hence show that P divides both DA and OB in the ratio m to n, where they are integers. Okay, so first we can form two equations for OP. So we know that OP is equal to lambda OB, and OB is C plus A, because we can go this way to find OB. So OB will be A plus C or C plus A. And this is the first equation. The second equation we can form is OA plus AP. So this one will be going this direction. And we know that OA is equal to A, and AP we know is equal to a scale factor of AD. And we can find AD. AD is AO plus OD, which will be minus A, because it's the opposite direction, and then plus 2 over 5C. Okay, so this is our second equation for OP. Now we can equate both of these equations. And I'm going to make all the A and C terms together so that it's easier to see. Okay, now we can equate the A terms and the C terms. So I'll be equating this and this to form this equation. I just cancel out the A, and then I can also equate this and this. That will form another equation. And because both of these are equal to lambda, I can just equate them. Now that we have this value, we can sub this into this equation to get the lambda value, which will then be 2 over 7. Okay, so now we can rewrite OP as 2 over 7 multiplied by A plus C. Okay. the second part of the question is that we have to show that P divides both DA and OB in the ratio. So OB is this part, and we want to show that the point P divides OB, which is OP and PB, in the ratio M and N. So we need to find OP and PB. Okay, so we already have OP. And then PB will be, we can go PO plus OA plus AB to find PB. Okay, so PO will be negative of OP, so you just change the signs. And then plus OA, which is plus A, and then plus AB, which is plus C. And then just simplify. Okay, I'm going to take out the factor. And then we can cancel 1 over 7 and the bracket A plus C. So the ratio will be 2 to 5. Okay, so the ratio of M to N should be the same for DA and OB, but I'll just do the same thing for DA just to make sure that is 2 to 5. Okay, so for DA, we are finding DP and PA, the ratio of this. Okay, to find DP, we can go DO plus OP. And DO would be minus 2 over 5C, and then plus OP, which is 2 over 7A plus 2 over 7C. PA, it will be minus OP plus A. Okay, so this will be minus 4 over 35C plus 2 over 7A. And then yeah, okay, so we can take out the factor of 2. This one will be factor of 5. Okay, so the inner part is actually the same, so you can just cancel out, and then the ratio will be 2 to 5, which is the same as OB. And yep, that is what we expect. So the ratio is 2 to 5. Yeah, that's it for this question. Okay, moving on. The diagram shows a triangle OBC. The ratio of OA to OB is 4 to 7. And since OA is 4 over 7, AB will be 7 minus 4, which is 3 over 7. And then OD to OC, the ratio is 4:7. This is the same, 4/7 and 3/7. And then OB is equal to B. So we know that this is 4/7C and 3/7C. And then OC is equal to C. So this is C. The point P is the intersection of AC and BD, such that this is where they are scalars. Find two expressions for OP, each in terms of B, C, and a scalar, and hence show that P divides both AC and DB in the ratio 4:7. Okay, so this is similar to the first question, and we can just find two equations for OP. Okay, so OP is equal to OA plus AP. OA is 4/7C. AP, we can use this. This will be lambda AC. To find AC, wait, sorry, I just realized this should be B. Okay. Okay, to find AC, we can go AB plus BC or OC minus OA. OC minus OA might be easier, so OC minus OA. OC is C minus OA is minus 4/7B. Okay, so I'm gonna collect the like terms. Okay, so I'm gonna separate the B and C. And this is our first OP equation. The next one we can form is OB plus BP. OB is B, and then BP, we can use this. Okay, to find BD, we can go minus B plus 4/7C. So we are going BO plus OD. Yep. And then I'm gonna collect the B and C. I'm gonna separate them. Okay, now that we have two OP equations, we can equate them to find the unknowns. We can equate this part to this part, and this part to this part. Okay, so I just cancel out the B and C for each of them. And then, yep. Okay, so this is equal to 7 over 11. And then I'll sub this back to find the lambda value, which should be 4 over 11. Okay. So we need to show that P divides both AC and DB in the ratio 4 to 7. Now we know that AP is equal to 4 over 11 of AC. So that means AP is 4 and PC is 7 because 11 minus 4 is 7. So that means P actually splits AP and PC in the ratio of 4 to 7. So this is AP, this is PC. So yes, they're split in 4 to 7 because of P. And then for BP is equal to 7 over 11 of BD. And this is the line. Sorry. So BP is 7/11 of the entire line. That means this is 4 over 11. And we want to show that P divides DB in the ratio of 4 to 7. And DB is, we're going backwards, so it's DP and PB. DP to PB. We're finding the ratio of this. And DP is 4, PB is 7. So yes, it's also 4 to 7. So that's it for this question. Okay, part B. The point Q is such that OQ is equal to this. Use the vector method to show that they are collinear. Justify your answer. Okay, so we can use OP from the previous question. Let me just find it first. Okay, so 4 over 11b plus 4 over 11c. Okay, so this is the OP value. And we can also rewrite OQ by taking out the factor. The reason why OQ and P are collinear is because both OP and OQ are scalar multiples of B plus C. And both of them have a common point, which is O. So OQ and P are collinear. Next question. A particle P moves with a speed of 14.5 parallel to the vector this. Part A, find the velocity vector P. Okay, so we need to find the magnitude of the vector and then compare it to the speed given so that we can find the velocity vector. To find the magnitude, we just need to use Pythagoras. and we should get 29. So if we divide 29 by 14.5, we'll get 2. This means that the vector here is 2 times of the speed vector. So to find the velocity vector of p, where it moves at 14.5, we would have to half the velocity vector given. So this would be the answer. Okay, initially p has position vector 3, 5. Write down the position vector of p at time t. Okay, so we need to know the formula.
Position vector equals the initial position plus velocity times time.
Position vector is 3, 5. Velocity vector is what we found in part A. And then time is t. So we can simplify this a little bit. And yeah, this is the final answer. The second particle q has position vector this at time t. Find in terms of t the distance between p and q at time t. Simplify your answer. Okay, so from part B, we know that the position vector of p, OP, is this. And this can be rewritten as this. We can also rewrite OQ. We can write that as PQ, which will then be OQ minus OP. And we'll just sub everything in. Now we need to find the magnitude of this vector using Pythagoras. Okay, so we're just expanding this. And then simplifying it. And this should be the final answer. Now we need to show that P and Q never collide. So for P and Q to collide, the distance has to be 0. So we need to show that the distance can't be 0 for them to never collide. And since we have the distance equation from part C, we can equate that to 0 and show that it will never actually be 0. Okay, we can use b squared minus 4ac. B will be minus 28. A is 34 and C is 20. And this should be minus 1936. So since b squared minus 4ac is less than 0, there is no real roots. And distance between P and Q will never be 0. This means that the graph will never touch the x-axis, so P and Q will never collide. Okay. Next question. The diagram shows triangle OAB. The point P lies on AB. The ratio AP to PB is 1 to 3. So AP is 1/4 and PB is 3/4. Given that OA is equal to A and OB is equal to B, find an expression for OP in terms of A and B. Simplify your answer. Okay. To find OP, you can go OA plus AP. And AP will be 1/4 of AB. So it's going that way. And we can find AB. AB will be minus A plus B. Or B minus A. Okay, so OA is A plus AP is 1/4 of AB. Okay, so that's OP. Vector Q has magnitude of this and direction of that. And vector R has this magnitude and that direction. Find the unit vector in the direction of Q plus R. Okay, first we need to make sure that the vector is the correct one, as it must match the magnitude. So we will find the magnitude of the vector first for Q. And it will be 3/5. And let's take the magnitude divided by the magnitude of the vector, and it should be 4. So we know that the magnitude is 4 times of the vector given, and what we want is the magnitude, so we'll take 4 times the vector given. So this is for Q. And we'll do the same for vector R. We find the magnitude, and then we compare with the actual magnitude given. 15√2 divided by 5√2 will give 3. So the magnitude is 3 times of the magnitude of the vector. So we need to take 3 times the vector direction, the vector of the direction. So this is R. Okay, now we need to find the unit vector in the direction of Q plus R. We have the actual values for Q and R, so we can add them up first. And for vectors, you just multiply them normally. So it will be this. Okay, now that we have the vector for Q plus R, we need to find the unit vector. And unit vectors only have magnitude of 1. So we can find the magnitude first. Is 3√10. And then we can divide the entire thing by 3√10. And this will be the unit vector in the direction of Q plus R. Okay, so that's it for this topical walkthrough. Thank you for watching, and I hope that this was helpful.